Alright guys, so let's summarize what we've learned from our lab investigation regarding voltage, current, and Ohm's law. So we saw that when we increased the voltage, the current changed at a constant rate. If we were to graph that, we would actually get a linear function that looks like so. And because this is a linear function, we can actually apply our linear relationship y equals mx plus b. Notice that the b goes to 0 because our y-intercept is at 0. If there's no voltage, there's essentially no current. So we can translate our y and our x variables using v and I, voltage and current respectively, as our independent and dependent variables. So if we were to do that, we would actually get the following relationship. V equals your slope times I, and your slope is actually going to represent the resistance R, which is a measurement made in ohms and determines how much current is going to be in the circuit. So this is the fundamentals of Ohm's law. You might see a more familiar version using the equation V equals IR. So if you have the current and the resistance, and you can multiply them together to get the voltage. Another form of this equation to solve for a different variable would be I equals V over R, which is the current. Now, the last form to calculate the resistance is just simply R equals V over I. So now you have a way to calculate voltage, current, and resistance if you're given 2 out of those 3. And this more generally is the relationship demonstrated by Ohm's law, which is summarized by focusing on the equation for current. The fact is that current is directly proportional to voltage, so as voltage goes up, the current goes up, and inversely proportional to resistance. So as the resistance goes up, the current goes down. Now, what are the factors that affect resistance? Really, you need to look at the wire thickness, the wire length, and the wire temperature. So the thicker, the longer, and hotter a wire, the greater the resistance. So we can also translate all of these variables to help us calculate a different property of the circuit, and that is going to be the power of the circuit, which is measured in watts and is given by the equation I times V. Now you can substitute for the voltage using our I times R equation from above, and then in that case we would get I times R, which just becomes I squared times R. So that's how you would calculate the amount of power a circuit is generating in watts. One thing I want to note is that Ohm's law is applied differently in series versus parallel circuits. These notes will come soon. I want to use those notes to help you introduce the concepts for worksheet 3, but that'll happen after quiz 2. For your quiz, you will need to know how to use these equations. You could also benefit from knowing that the slope of a voltage versus current graph gives you the resistance. So that is the info you need for the foundational understanding of Ohm's law. More will come when we talk about Ohm's law in series and parallel circuits.